Okay. All right. Ellipses. All right. So, ellipses is a set of points of all the points in the plane, the sum of whose distances from two fixed points is constant. These two fixed points are called the foci. The midpoint of the line segment between the foci is called the center. And the ellipse has two lines of symmetry. It has one called the major axis and one called the minor axis. So we're going to label those on these pictures that we have here. Oh, sorry. Here we go. That's better. All right, so, yes. Okay. So, and I'm going to show you guys something here in a second as well to help. So, an ellipse is going to have 2 points right here and here. If it is a wide ellipse, ellipses can also be tall ellipses, or it could be like here and here. These points right here are called the foci. Individually, it's the focus, but there's always two of them for ellipses. So, and I used to teach this and tell students that I have no idea why you need to know the foci. But I'm going to show you guys in a second. I realize now why you need to know them. All right, then the center is going to be halfway between that, so this would be our center. Actually, I don't need to write that there, because that's going to overlap with my axes. Let's put this right here. I don't know why it's making all these weird lines. And then you're going to have a major axis. It is your longest axis of symmetry. So for a wide ellipse, it's going to be the horizontal line. But for a tall ellipse, it's going to be the vertical line. Sorry about all these crazy lines that are popping up. And then the shortest axis of symmetry for a wide ellipse, that would be your vertical line. It's called your minor axis. And for, this is going crazy. So, those 2 points that are called your foci are really important for being able to draw the ellipse. So let me find, I should have got this out for class, sorry. Let me find my board. Alright, rubber band is not the best thing. No, I can't use that rubber band. Let's see, do I have any string? The string has fell off. You will have a hard time with that game right there. Is that a calculus game? Yeah. We may try to do something like that sometime, but definitely can't play that one because it is calculus. I bet I can do it. And they were having a little bit of trouble with it. It's pretty hard. That's easy, guys. I need it to be a circle. I think I'm going to have to use the rubber band. The rubber band is just not good because it's stretchy, which is not ideal. But not the best to use here because rubber bands are stretchy, and I'm going to have to stretch this out. So, the, what's happening here? It's probably pressing a key. Right there. Let's see if it'll work now. Yeah. Alright, so, might just be best for me to do this, see if the document camera will pick this up, and then my missing students will be able to see it also. Alright, let's see. Oh, wait. Okay, so, let me do document camera real quick. Good gracious. Alright, document camera. Alright, so ideally I would not be using a rubber band. I would have a piece of string that was tied into a circle, but I was not prepared for my lesson today. So, the definition of an ellipse is all of the points that are equidistant from two fixed points. Okay, those two fixed points are your foci. So, what happens here, if I put my pencil right here, you can see that this length right here does not change. Imagine this is not a rubber band that is not stretchy, because I realize it will stretch, so it could be different lengths. But if this were a piece of string that would not stretch, whenever I move along the ellipse here, the length of this side and this side would always have to add up to be the same, right? These two lengths would always have to add up to be the same if it were not a rubber band that would stretch, right? Because that circle would always have to have the same length. So, to draw an ellipse, if you just put two nails in a board like I have here, and you take your string, preferably not a rubber band, and you just go around like this. Mine's not very good because my rubber band is stretchy, but I'm just following my lines from last time. Then if you do that, it will create a perfect ellipse. So, you can change the shape of this ellipse based on how close together your foci are, or how far away they are, and how big your circle of string is, right? If I made, I can't really do it. Like if I had if my string was longer, I could do one that was larger here, but since I don't have string, it makes it more difficult to do because you can't do it with rubber bands, so it's stretchy and it doesn't want to stay. You could do this like with a circle. A circle, you have maybe done that before, where you just put a nail in a board, tie a pencil to a string, and you can draw a perfect circle, right? It works like this. I'll try to bring my a piece of string tomorrow so I can show you guys again how it works a little bit better, but hopefully you get the idea. So you can make any ellipse that you want. And I used to say I didn't really know so much about why you want to know foci, but a few years ago, I wanted this a yard sign like this one right here. However, this particular yard sign costs $189.99, and I did not want to pay nearly $200 for this yard sign for Christmas. So, at the time, lumber was lower too, so I sent my husband to Lowe's to go get a piece of plywood that cost like $30 or $40. It was not very expensive. And I drew out a J, easy. I drew out a Y, not hard either. And then I came to this, because that was much more difficult to do. And what I was really worried about is that I knew that it would look terrible if my circle if my ellipse was not correct. because if my ellipse was not correct, it was going to look all wobbly and weird. And I was making it like 4 feet high, so getting that to be perfect was going to be really hard to do freehand unless you're just really good, and I'm not. So I was super excited about this too. I was so excited that I figured this out. So I knew like how tall I wanted the O to be, and I knew how wide I wanted the O to be because I wanted it to like match in with my J and my Y. I wanted the same height and the same and like a comparable width, so it was proportional. So I knew what I was looking for, so I could take that information, work backwards, find out where my foci were supposed to be. I put my foci on my board, and then I knew like how long to make my string, and I could do what I just showed you here with those 2 points and draw the outside. Then I had to like refigure it for the inside, so that I had another smaller ellipse, and that got me the O perfect. Now I had to like freehand this other stuff, like the nativity scene. I had to like freehand that, but I could go back and fix it a little bit, and it was smaller. But it got me that perfect O. And every year, I think that I need to have a picture of the actual sign that I made because it's starting to get a little, it needs painting again. It's starting to get a little like weathered. But it looked so good. Maybe not quite this good, but really close. But it's like in my basement in the back corner, and I never think to drag it out whenever we're doing this. But I was usually, except for sometimes I'm bad at decorating for Christmas, and well, I need to get it out. But sometimes my Christmas decorating is becoming not great sometimes. So. No, I usually wait till after Thanksgiving, but we won't start that debate right now because there's some strong feelings.
We don't have Thanksgiving at our house.
Uh-huh.
We put up so much that we don't turn it on. But Dad's like, we don't go ahead and start putting it up. If we wait till after Thanksgiving, we ain't gonna get it up till
Yeah. I do understand. Sometimes I will put mine up before Thanksgiving, but we don't turn it on until after. Yeah. So, but no, my mother-in-law and my sister-in-law will have their houses fully decorated by the end of the week. Probably. Yeah. They'll probably, and they do a lot. But anyway, I'm gonna make sure I'll get it out. So if you ride by my house, you'll see my ellipse here. But I was so excited, and this would not just be for like yard decorations, of course. That cost me like $35 by the time I was done. A little bit of white paint that I already had. It was easy. So anytime you needed an ellipse of a certain size, if you find the foci, then you can use it for that. So that's why you need to know about it. All right, let me go back to notes. Okay, we will be focusing on the equations primarily. I think I have a couple challenge problems I might give to you. Also, if you've been working on the arch problem, if you tried it any. Jeremy and I were thinking that radius should be between 1 and 1.5 the other day. That's false. Your radius is going to be bigger than 1.5. Your radius is going to be bigger than 1.5. So, if you've been thinking about that problem, remember that it's extra credit. I feel like after working it out, it might be worth 10 points if you can explain it to me well. It's pretty tough. And you have to have the exact answer, not like a close enough answer. Exact answer. Okay. All right. So, ellipse. Okay. It is kind of similar to a circle in ways. You can see you've got this x minus h squared and the y minus k squared. You have the plus sign in between. That part is similar to the circle. Your center will be HK. But underneath each one of these terms, you've got an A squared and a B squared. And this should always be equal to 1. A is going to be the distance from the center to the vertex horizontally. It is horizontal because it's underneath the X, right? And the X is our horizontal direction. And then B is the distance from the center to the vertex vertically. So you would go up or down, whatever value you have here. A and B, for this to be ellipse, should be different numbers. If A and B are the same number, what do you have? You've got a circle, right? If you go left or right 5 and up or down 5, you actually have a circle. You don't have an ellipse for that. So if A and B are ever exactly the same, you should have done it like a circle instead. So graphing these is pretty straightforward as long as they're already in standard form, like you had for the circles the other day. So center of this is just going to be just like the circles. It would be at 2, -3. So we would go to 2, -3, and we would graph our center. And then right here, underneath my x, I have 25. I'm going to take the square root of that. That's going to give me 5. And that is my horizontal distance. So I will go 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5 to the left. For the y's, I'm going to take the square root of 9. That gives me 3. I'm going to go from the center, go up 3, and down 3. And draw in that ellipse. There. Yep. Actual ellipses are probably not exactly as much football shape as what I've drawn here, but I guess footballs are a little pointier on the end than ellipse, but you guys get the idea. Alright, so if I had this one, my center would be at 0, 2. Okay, how much should I go to left and right? 2. Go left 2, right 2. How much should I go up and down? 6. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And then you'll draw that ellipse. And yeah, mine's not great either. But as long as you've got that, I would highly suggest actually including these points right here. And these will mostly be on Canvas where it's multiple choice and you're matching them. But if you are asked to graph anything by hand, put those points and make sure that you cross through them. Because, yeah, it's really hard. It's harder to draw than a circle, I think, to draw it well. So you can see if you have the bigger number underneath the Y, it makes a tall ellipse. If you have the bigger number underneath the X, it makes it a wide ellipse. There. Okay. This one asks us to write the equation from the ellipse. So it would start off looking kind of like a circle. You got a center right here at 3, 2. So that would be x minus 3 squared. And then you'll have a y minus 2. No, I've got that backwards, don't I? It should be 2, 3, shouldn't it? Yeah. Let's switch them. This is 2, 3. So x minus 2, y minus 3 squared. Ellipses in standard form are always going to equal 1. And then to find the number that goes underneath my x, I'm going to go from one of the vertices over to the center. And I've got 1, 2, 3, 4, 5, 6, 7 for this. So since that is 7, I should put 49 right here. And then vertically, that length right there is 4. So 4 squared will give me 16. All right, here. Okay. Let's do one more of these. Center for this one is -3, 0. So that's going to be x plus 3 squared plus just a y squared. Standard form of ellipse is always equal to 1. Horizontally, I've got a distance of 3 right there from the vertex to the center, so that'll be a 9. And then vertically, I've got 1, 2, 3, 4, 5, 6, 7. So that'll be a 49 right there. All right here. Okay. All right. So, we need to be able to find the foci. It is important to note foci are always on the major axis, so that's your longest axis of symmetry. So if you had a wide ellipse, then you're going to have your foci on the horizontal axis. If it's vertical, you'll have it on the vertical axis. So this formula right here is going to give you the C value for the foci of an ellipse. I need to, pre-cal does not have a state test anymore. When it did, they gave us a formula sheet, and this was on the formula sheet. So for this test, I will give you that formula sheet that we have. And so for the foci of an ellipse, we know C squared equals absolute value of A squared minus B squared. Okay, so for like this problem, your C squared would be absolute value of 25 minus 9. So C squared would be the absolute value of 25 minus 9 is going to be 16. And if we square root both sides, C is going to be 4.
I have a question.
Mm-hmm.
So, since it says A squared, why would I have to square?
The A is the distance from the center to the vertex on the outside. So, like if you're thinking of graphing this, you would just go to the right 5, left 5. So this number is already squared. If you go back to the formula that we had over here, that number is already your A squared. So it is already squared, so you just use those two numbers right there. And so what this is this is our focal length, which is the distance from the center to a focus. Right, so I'm saying focus because we're only talking about one, but it's either one there. So from the center to one of the two foci, the distance for that should be 4. Okay, so you're going to use your center and add and subtract your C value to or from the variable on the major axis. So let's think about what happens for this problem. What's the center of this ellipse? 2, -3. I like to draw a picture, a rough sketch of a picture. Is this a wide ellipse or a tall ellipse? It is wide. How do we know it's wide, Caleb? Good. We will go out 5 on either side, but we'll only go up or down 3. So this one's going to be wide. So I'm just drawing me like a really rough sketch, not actually graphing it, just a really rough sketch. I know that the center right here is at 2, -3. Right? And I also know that the foci have to be on the major axis. So that means they're going to be like right here and right here, to the left and the right on this problem. And I just found 4 as my focal length. So this right here would be 4, and this would be a distance of 4. Right? So if I'm looking for the point over here on the right, what would I have to do to that point to -3? Add 4 to which coordinate? The x coordinate, because I'm moving to the left or right. Right? So this would be at the point 6, -3. Right? I'll just be adding 4 to my x coordinate. So my foci here, one of them would be at 6, -3. Okay? What about the one that's over here on the left? Subtract 4, again from the x-coordinate. So 2 minus 4 would give us negative 2, negative 3. So our two foci points would be 6, negative 3, and negative 2, negative 3.
So what's the difference between that and the 5 that you have to extend?
So if the 5, that would give us what we call a vertex. So like when you're graphing it, you don't need to know the foci because you would just go from the center all the way over to the edge. You would go out 5 right here. And then same thing for vertically, you would go up or down 3. The foci is going to be, it should always be shorter than that distance from the center to the vertex, right? Because it's going to be on the inside of the ellipse. And we use this formula to find what that's going to be. If the number underneath the x is bigger, it's going to be y because you'll go further to the left and right than you do up and down. If it is the number underneath the y is bigger, it'll be tall. Okay? So you will have to find foci, but you will be given the c squared equals a squared minus b squared formula for that. Probably not, but I'll show you how we're going to deal with roots. I meant to check on to see if it's calculator active or not. I can't remember. I might, just because these are like, you're not going to be able to graph these on the regular calculator anyway because they have x and y. Desmos will graph it, but the regular calculator won't graph it easily. So if we want center and foci for these ellipses. So for number 1, all right, for our center, we're just going to have negative 4, positive 10. Okay. Maggie, is this one going to be wide or tall? It's going to be wide. Okay. We know it's wide because 121 is underneath our x and it is bigger than 81. So my center right here is at negative 4, 10. So I am looking for the foci that will be on either side. So to do that, I need that c squared equals absolute value of a squared minus b squared, which for this one is c squared equals 121 minus 81. So c squared is 40. If we square root both sides, c is going to equal the square root of 40, which is not a perfect square. We could break that into 2 root 10, right? So we're going to do these just with roots. It could be asked with decimals where you actually get a decimal number, but we're just going to do these with roots. So that means the length from the center to the focus is 2 square root of 10. So if I want to know the coordinates of this point over here on the right, I need to add 2 squared of 10 to which coordinate? The x. So I would get negative 4 plus 2 root 10. 10. Sorry for that line there. And if I wanted to find the other focus on the other side, what would it be? Negative 4 minus 2 root 10. And then the y coordinate would just stay 10 there. You can write it this way. Negative 4 plus or minus 2 root 10. 10. If you would like, you could put them as the same. Put them together there and just use a plus or minus. If you have whole numbers, I want you to go ahead and find the 2 distinct points. Don't write it. Like on that last one, I would not want you to write it as 2 plus or minus 4, negative 3, just because you can find a better answer, right? It is correct, but it's just there's a better answer. For these, it's perfectly fine to write them together if you want. Okay. Okay, here. All right, for number 2, I've got x minus 2 squared over 36 plus y squared over 49 equals 1. My center for this one is going to be at 2, 0. Okay. Kayla, is this one tall or wide? Is tall. And I know my center is right here at 2, 0. I need to find that focal length, that C value. So C squared is going to equal the absolute value of 36 minus 49. Here is the reason they have those absolute value bars. What is 36 minus 49? Negative 13. But what does the absolute value bars do to it? Make it positive. And then you got the square root. So C equals the square root of 13. So this time, that focal length, our foci are on the vertical axis. So that length right here is the square root of 13. So if I want to find that top point, what should I do? Add root 13 to the 0, the y coordinate this time, because we're going up and down. That's why I like to draw the picture when I'm doing it, so I can keep straight whether I'm adding to the x or the y. So this would be 2 square root of 13. What would the bottom point be? 2 and negative square root of 13. If you want to write 0 plus square root of 13 or 0 minus square root of 13, you can, but it's more standard. Yes. So you could give your answer like this. Or if you give them separately, it's fine too. Either one is acceptable.
So if it was a decimal, can we change that into a decimal? Would we actually add that number?
Yes. Yeah. Yeah. So like if we needed a decimal answer, like whenever I did the drawing, when I made the foci, I had to find where those foci were at. And really what I needed was the focal length. I needed to know how far apart to put my nails on my board. Whenever I did that, I needed to change it to a decimal because it did not help me to have 2 square root of 10 inches, right? So you would definitely want to change it in some instances. As far as like pure mathematics go, they usually don't. They usually leave it roots. I think that it is either going to be whole numbers where you don't have to worry about it, or it's going to be multiple choice. So you'll know which one it's supposed to be. Yes. Yeah. And we'll go over the homework before we. You'll either have that or I'll write them on the board if I forget to write them. The formula sheet that they used to give for pre-cal that gives you that focal length is the only thing that you really need. So I may just write on the board for that. But, all right, so all axes run through the center. So one axis will be at x equals h and the other will be at y equals k. Okay, right? Because whenever I think of an ellipse, whether it is vertical or horizontal, right? I've got h, k. Right, I'll have a vertical and a horizontal. Right, I could also have a wide ellipse. That center is at H, K. We've got vertical and horizontal. Okay? So, horizontal lines. Is it x equals the number or y equals the number? It is y equals a number. Vertical lines. Vertical lines are x equals a number. It's backwards from the axes. Because if you have vertical points that line up vertically, all of their x coordinates are the same. If you think about graphing it, like if you have x equals 2, right, then the x coordinate has to be 2. So like 2, 0, 2, 1, 2, 2, 2, negative 1, 2, negative 2, right? All the x coordinates have to be 0. They all have those same x coordinates there. So x equals is a vertical line, y equals is a horizontal line. So this horizontal line right here, it would be y equals the y coordinate, which is k. This vertical line would be x equals h. If we have it's the same thing over here. This is still y equals k, and this is still x equals h. It's just which one's the major and minor is going to switch, right? Okay, so let's first consider the wide ellipse. Okay, if I have the wide ellipse, which axis is going to be my major axis? The y equals k or the x equals h? Y equals k. Okay, so y equals k is the major axis if it's wide. How can I tell from the equation if it's wide? The number underneath your x is bigger than the number underneath your y. So I'm going to say A is greater than B. And we might want to write below it wide ellipse. Right. So for a wide ellipse, y equals k is your major axis. Okay. For your tall ellipse, for that tall ellipse, B is greater than A. And for that tall ellipse, x equals h is your major axis. That vertical line is your major axis. Here's what's tricky about that. Well, we'll do one of the other problems. But whenever B is bigger, x equals h is your major axis. When A is bigger, y equals k. So it's not the one that's there with it. It's the opposite there, which can be confusing sometimes. There's going to be a major axis problem on the quiz tomorrow. Major axis should be a very easy question, as long as you know what you're doing on them. But it's really easy to forget about the major axis, right? So let's look at this problem. We need center, we need foci, and equations of the axes. Okay, so let's do center. Everything stems from the center, so you always want to find it first. This one would be 4, negative 4. For our foci, we would do that c squared equals absolute value of a squared minus b squared, which will be c squared is absolute value of negative 140. So c is the square root of 140. 140 breakdown. We're not going to spend our time worrying about whether or not 140 breaks down. It'll be multiple choice. I don't think it's going to matter. If it does break down, you'll be able to recognize that happens. So let's think about, I need a picture of this so I can picture what's going on here. Is this tall or wide? Tall. Okay, so I just found that the center is right here at 4, negative 4. Okay, so my foci are going to be above and below that, right? Which coordinate am I adding the square root of 142 and subtracting? The y, right? Because I need to go up and down. So this is going to be x coordinate stays the same. I've got 4, and then I'm going to have negative 4 plus or minus the square root of 140. I think it is so helpful to have the picture. So, major axis. That is our longest line, which for a tall ellipse is our vertical line. All right. vertical lines. Is it x equals or y equals? It is x equals. Right? So for this equation, what does the x equal? H, and our H is 4. Right? Because it's your x coordinate of the center. So my major axis would be x equals 4. The minor axis, that's this here. It is a horizontal line, which is going to be y equals. And what does y equal? Negative 4. Yes, you want to look from the center. Don't use the focus for your major and minor. Yeah, just use the center. Like, I could ask you major and minor without you ever having to find focus. I was just putting all those together in one problem. So, like, whenever you have a major axis problem, it'll look like this. It'll say find the major axis. So you'll need to know the center first, and then you'll decide whether it's that vertical or horizontal and proceed from there. Okay? All right, now, here is culminating problems here where they look like they did yesterday. They are not in standard form. All right, so we figured out how to find focus, center, foci, center, everything from the standard form. This one's not in standard form. So yesterday, what's the first step that you did yesterday? A equals 1. Can we put the A1 sauce on this? We cannot, because if we do, which one do we use, right? Because 4, I have a 4 with my x squared, but I have a 9 with my y squared. So we're not going to be able to do these problems the exact same way as what we did yesterday. Because yesterday we could divide through by whatever that number was in front of our x squared, because it was the same as whatever was in front of our y squared. But it is not the case here. So in a way, we still have to use A1, do the A1 thing, but we've got to do it differently than we did yesterday. So, so let's group our x's and our y's first. So 4x squared minus 40x, and then I've got 9y squared plus 36y, and I'm going to go ahead and take this 100 over to the other side, so minus 100. You're here just in time for the fun. Okay. All right, so we still, to complete the square, we still need A to be 1. So what we're going to do, since they're different for our x and our y's, we're going to treat them separately. I can't divide off the 4, but I could factor out the 4. Right? Put the 4 out here, which would give me x squared minus 10x. And I'm going to go ahead and put a plus blank here because I need to complete the square for that. And then over here, I can factor out the 9. You always need to factor out whatever is in front of your y squared there, even if it doesn't go into the second term evenly, but hopefully for most of them it will. So you get y squared plus 4y. I'll put a plus blank here. And then I'll have over here negative 100 plus blank plus blank. You don't want to, because it's going to make it where you can't complete the square, because you need an x squared to complete the square. It would work, but then it's not. You're not going to be able to do the next step with it. So you want to leave the x in there. So we want to complete the square for x squared minus 10x plus blank here. So this is the same thing we were doing yesterday. Just let the 4 hang out front. Okay. We wanted this to be something squared right here. So we'll have x right here. 10, we're going to divide it in half, so we'll have a minus 5 right here. What number do I add in this blank right here? 25. What number do I add over here? Not 25. Not negative 25. 100. Kayla, why did you say 100? You got to multiply it by this 4 right here because you added a 25, but that 4 would have to be distributed right there, so it's really like you added 100. So that's the trick to these problems you have to really watch out for, because if you forget to do that, you'll get it wrong. You got to, whatever you add right here, you got to multiply by that number out front before you add it to the other side. We didn't have to do that yesterday because we didn't have a number out front, right? It was just a 1, so it didn't change anything. All right, so we're going to do the same thing over here. So y squared plus 4y plus blank, we need to factor that and complete the square. So it'll be y plus 2 right here. What number goes in the blank right here? 4. What number goes in the blank on the other side? 36. We got to do 4 times 9 to get that 36 right there. And this is going to equal just 36 when we combine all 3 of those numbers. So it's similar to what we were doing yesterday, but we got this extra step of having to factor those numbers out, right? And that's going to happen every time because it's not an ellipse if they all have the same number, right? Now, what does the standard form of an ellipse always equal? It always equals 1. But right now,
You gotta divide it by 9 or 4, whichever one you want.
Actually, you're on the right, in the right path, but I need this number right here, this 36. I need it to be 1.
Yeah, that's what I'm saying.
So,
You can divide the 36 by 4 or 9.
but I want it to be 1. If I divide it by 4, it's going to be 9.
Yeah, then you divide it by 9, it'll be 1.
Or I could do it all at once and just divide by 36, and then it'll be 1. Okay? You're on the right, you've got the right thought process there. Alright, so if you divide everything by 36, now these do not always simplify, but most of the time they will. If I reduce 4 over 36, what could I divide both of those numbers by? 4. So divide by 4 here, divide by 4 here. I will get x minus 5 squared over 9. And then over here, 9 over 36, what could I divide by to reduce that? 9. And usually what happens for a lot of these anyway is they are just going to switch places, right? That 9 goes to the bottom here, the 4 goes to the bottom here. It doesn't always happen that way, but because textbook problems try to give you whole number answers, it does a lot. Mm-hmm.
Okay, question. So if those had divided evenly and we would have had a number outside of the parentheses in the numerator, how would we have found the center of that?
What we really want to do is we really want to just always divide by whatever number is here. So like, let's pretend it was a 3. We would just divide the top and the bottom both by 3. And it would reduce to x minus 5 squared over, well, that actually goes evenly. That would be 12. But even if it was like 2.5, we could divide the top and the bottom by 2.5. That'll give us the 1 on the top, and it'll give us a decimal on the bottom, which is definitely probably not going to happen like on the quiz tomorrow. Because,
So we'll always
but
be able to take the...
usually, there might be a few where you don't, but for quiz questions tomorrow, I think you should have whole numbers for that. And so it wants us to find center, foci, major axes, but I think we're going to skip that and go do the last problem real quick because we need to see all of these. Here. Or this may not be the last one. Next to the last problem. All right. So, same thing for this. I want to group my x's. And I need to group my y's. And that 116 is already there on the other side, so I don't have to change its sign. And then you've got to factor out that greatest common factor there so that you can complete the square. Because this is the point where you have to break out the A1 sauce, because you cannot complete the square till A equals 1. It's just separate and whereas last time we could do it for everything. So we got x squared plus 4x plus blank. And then over here, we're going to factor out a 9, which will give us y squared. That should be a y right there. Minus 2y plus blank equals 1/16 plus blank plus blank. Okay. So we want to complete the square on each one of these. We'll have x. We got a 4x right here, so I'll put a plus 2. What number should I add in this blank right here? That'll be a 4. But what number has to get added to the other side? 100. Okay. Then for the second one, I'll have y minus 1. What number goes in our blank right here? 1. What number goes in our blank on the other side? 9. Okay? So when I add those together, I'm going to get 225. I believe so. And I'm going to divide everything by 225 because I need this to equal 1. And if we divide by 25 on top and bottom, we'll get a 9 right there. If I divide by 9 on top and bottom here, I'll get a 25, and that'll equal 1. So it'll be in standard form. So we can circle, we could graph it, we could find the ellipse, all those things. Okay, questions? All right, we are out of time today. All right, so, where is, yes. They'll have ellipses, but we'll go over this, over homework before we take our quiz. All right, so homework is, I think it's a textbook page, if I remember correctly, but let me look at it. Yes. All right. Oh, wrong thing. Sorry. It is a textbook page. Gracious me, it's not showing up for me. Okay. It's on Canvas. 16 through 28. I'm trying to see if it asks you to graph. Sorry, I know we're at the end of class. Why is it not coming up? Do I have my book over here? No. Come on. Why are you not working? Let's try this. Alright, let's see. It asks for vertices. You do not have to graph. You do not have to do vertices. Those are just the numbers you get when you graph. It does ask you to graph these. So if you would like a sheet of graph paper for your homework, I have some here. So if you want graph paper, do a piece here from me. Or you can sketch a graph, but this will be easier. You're welcome. I need to check. I think it's not the correct answer, so it does not end up mattering that it was there twice. But I will double check it because Luke did ask me about that one the other day, and I forgot to go back and look at it.
Okay.
If I remember right, it is. I think it's not the right
I
answer.
thought it was the correct
But
answer,
I will
so I just
check.
chose one of the two.
Yeah.
But once again, you've been doing this for
Yeah.
a lot longer, so.
That is just off the top of my